What's poppin', dogs? Mr. Allen here with some application of exponential functions. We have the graph models the growth of a social media account right over here. They started tracking the growth when the account hit 2,000 followers. The account grows at 30% per month. We want to write a function to model the growth, and we're going to make a prediction of how many they should have by month 12. All right, so first off, they started tracking this when they hit 2,000 followers, which is why we see it at the 2 right here. This is followers in thousands of followers, okay? So that's our initial point right there. That's our y-intercept of this graph. Now we're growing at 30% per month. So what does that mean? Well, let's just type in some numbers here. If I have 2,000 followers, right, and I increase by 30%, well, I can multiply by 0.3, which would give me 600, and then if I add the 2,000 to that, I'd be at 2,600, which is why we see a point kind of right between the 2 and the 3 right here. Or what you can do is, to make it a little bit easier, I could just multiply this by 1.3. That would also give me the 2,600. And if I multiply by 1.3 again, now I'm at 3,380. So we got 3,380 right there. And then if I multiply it again, it's 4,394, so on and so forth. I just keep on multiplying by this 1.3. Interesting. Perhaps there's a better way. We could write a function, right? I mean, that's part A. We should probably do that. So we got f of x right here. My initial amount, my y-intercept, this number's not always the y-intercept, but it's a good starting point with these application ones. The initial amount here is 2,000. Now, my base of this exponential function, what's that going to be? So because it's growth, we're going to do 1 plus that 30% as a decimal, so 0.3, and we'll raise it to the x. So let me just rewrite this real quick. F of x equals 2,000 times 1.3 raised to the x. You could just get that right off the bat. I want to show the plus because if it's decreasing, then it's going to be 1 minus 0.3, and we'd have 0.7 in the parentheses there. But now what this is going to do is, instead of me having to multiply by 1.3 over and over and over again, I can just plug anything I want in here for x and figure it out. For example, based on this model, how many followers should this person have by month 12? What if I just did this? F of 12. Evaluate this when x equals 12, 1.3, raise it to the 12th power. Let's see. This person might be, rolling it, rolling in with the followers here, times 1.3. Actually, I'll throw that in parentheses so it looks just like that. 2,000 parentheses 1.3, close them, raise to the 12th. Note the caret there right above the division sign. That's how I can type in any exponent I want. Super helpful in the exponential unit. Oh my goodness, 46,596.17. So like about 47,000 followers. We'll go ahead and just round this to the nearest follower. So 46,596 followers. Dang. Now, if they said round to the nearest 1,000 followers, we would say the 6 would get rounded up by the 5. That'd be 47,000. That's if we're rounding to the nearest 1,000 followers. That's a common way to phrase questions in these applications. Not to the nearest 1,000th, which is 3 decimal places. We're talking to the nearest 1,000 place, which would be this guy right here, which gets rounded up by the 5. Okay? So there we go, guys. Nice little application of exponential functions. They're exponentially fun, if you will, and super helpful to know how to type this kind of stuff into your calculator. So pay attention to those keystrokes, and I'll help you guys out along the way. All right, that's it. Thanks for watching, you guys, and have a great day. I've actually got one other thought right here. One other thought. A little question off the cuff. I've seen this question at... I've actually got one more question for you guys that was not asked on here. So, what is the average rate of change, let's say from month 3 to month 4? What is the average rate of change? What is the average rate of change from month 3, let's go to 5, to month 5? Okay, so what's the average rate of change? Well, how would I figure that out? Let's see here. I would need to figure out what the amount is for months 3 and months 5, right? This is the slope we're talking about. Okay, hold up. This is the slope. So we're talking about the change in y over the change in x. In other words, if I did f of 5 minus f of 3 over 5 minus 3, I could get that job done. So we need to evaluate this function here at 5 and at 3 and throw this all in. Check it out. I can do this all in my calculator all at once. Ready? So we're going to hit alpha x to get a fraction. And I'm going to type in the 2,000 parentheses 1.3, close them, raised to the 5th, minus 2,000 parentheses 1.3, close them, raised to the 3rd, over 5 minus 3, which is just 2, right? But I'll type it all in so we can kind of see how it all is. See the exponents up there, the 5 and the 3, then you got 5 minus 3, all lines up nicely. Hit enter. My average rate of change is 1,000, so yeah, 1,515.93. We'll say 1,516. What does that mean? What is the rate of change here? This means that an increase, okay, so an increase of 1,516 followers per month from months 3 to 5. Boom. So that is our average rate of change between 3 and 5 months. So it's the increase, this person increased in 1,516 followers per month between months 3 and 5. Now that could change based on how wide of an AROC, an average rate of change, we're trying to find here, but this is the per month rate over those 2 months, okay? That's another great question that's often asked on tests, and then they'll ask you to interpret it in the context of the problem, which is what we have right down here. Increase of 1,516 followers, about that many, per month from months 3 to 5. All right, there we go. Now we're done. All right, a little bonus math right there. Sorry to spring that on you if you weren't ready for some bonus math, but I love me some bonus math. All right, you guys have a fantastic day. Thanks again for watching, subscribing, and telling other people about these dope videos. So have a great day.